Hey chaps, ever tried writing a Django ORM query and realized the built-in expressions just don't cut it? Before we jump in, let's quickly recap Django's built-in expressions. We have used things like f for field operations, case when for conditional expressions, and func for wrapping SQL functions. But what if none of these fit our needs? That's where expressions from DjangoDB models comes in. It lets us define custom SQL expressions and integrate them seamlessly into Django ORM. The first thing that probably comes to mind when you hear this is, what is the difference between just using func class, which we already covered, for custom SQL? I have an answer for you. The func class itself is a custom expression. If we now follow the source code of func, we can see that it's inherited from expression, and it is created to be able to efficiently apply SQL functions like lower, upper, length to your code. On the other hand, Django's base expression class provides a lower-level API for creating fully custom expressions that are not just simple SQL functions, but can involve complex logics, conditional statements, or database-specific optimizations. Simply, it gives you full control over how an expression is translated into SQL. When creating a custom Django ORM expression, we need to understand how Django processes expressions internally. Let's jump into expression source code and review its possibilities. When we follow the expression source, there are a bunch of cached methods and dunder equal and hash. Not much. From this you can already understand that all magic is happening in base expression class. Let's jump into it. There we have a few key methods in this class that control how the expression is compiled, resolved, and used in SQL queries. Before we review them, one important thing to highlight is the constructor. It's very simple and takes an output field argument, which is common for all expressions that you have already used. Let's break down the most important methods of this class, starting with sSQL. This method is responsible for translating the expression into raw SQL. It's called when Django compiles a query and needs to know how to represent the expression in SQL syntax. It receives a query compiler, which should have a compile method and a database connection object as arguments, and should return a tuple containing the SQL string and the list of parameters that will be passed to the database driver. And if your expression includes variables like field names or values, you need to compile them separately using compiler compile method. Let's say we want to round a number and create a special expression for it. Here is our round value expression, which we'll use on the book price. It contains a constructor that takes a field name and the number of decimal places. In the sSQL method, we define what should happen during the SQL query compilation. Specifically, we construct the SQL round function call, ensuring that the field name is properly quoted using connection ops quote name to prevent SQL injection and handle database-specific syntax. Let's now construct the query to use this expression and annotate rounded price to one symbol after comma, and see how this was interpreted to the raw SQL. As you can see, we have our price field set in round SQL function, and now we can return values list with new annotated field. The next one is resolve expression. This is an important step that happens before our sSQL method gets called. Think of resolve expression as the preparation or validation stage. It's like getting all your ingredients ready before you start cooking. So, what does resolve expression actually do? Well, Django expressions can be a bit complex. They can refer to actual database fields, they might involve subqueries, queries within queries. or they might be based on some other calculated values. Resolve expression makes sure that all references are correctly linked up within the overall query. It ensures that Django knows exactly what each part of the expression refers to. Essentially, it organizes everything before SQL translation. Let's review the code sample. Here we have a resolve expression in play, which takes a bunch of arguments well documented in the original method and return expressions to be added to the query. In this custom expression, we are using same technique as in previous rounding example, but also introducing validation bit in resolve expression. If user specified decimal places more than 10, this expression will raise value error. Let's run it when the decimal place is set to 1, and we can see that it's executed correctly. And when we set it to 11 and run it, it will raise an error. And last one we will cover is get group by calls. Get group by calls is used when Django builds group by clauses. It tells Django which fields to include in the group by clause. When your custom expression is used in an aggregation like average, sum, etc., it's essential for correct grouping when custom expressions are involved. Let's check the example. Here we are finding the length of the field using our custom expression in the sSQL method, and grouping by this field by specifying it in the getGroupByCalls method. Before we run it, let's output the titles of all books from the database. Here you can see that we have 3 books, 2 of which have the same title. And now when we try to create a query which calculate a length of the book title and group it by this field, we'll use our custom expression, which look like this. We annotate title lengths using our custom expression, then count how many books have each distinct title length. Now let's output the raw SQL from this query. We can see that it's grouping by the first field, which is the title in this example. When we check the actual output, we can see that the results are correctly grouped. If we didn't overwrite getGroupByCalls, Django might not include length title in the group by clause, and ungrouped result will be returned. As we can see here, by running the query and removing title field from group by method. At the end of this video, I would like to share a useful feature for performing case-sensitive lookups on char field. By default, most databases like PostgreSQL and MySQL are case-insensitive, which may lead to incorrect query results in Django. To ensure your query is case-sensitive, let's introduce a custom expression. This expression is designed to perform a case-sensitive lookup. It takes field name and value as arguments and uses them in the sSQL method to construct a raw SQL query. As a result, we achieve a binary, case-sensitive lookup. Let's run it with an uppercase C in custom Django expressions title, and after that, 2 objects found. When we switch to lowercase and run it again, we can see 0 book is found. And that's a wrap. Now you know how to build custom Django ORM expressions for greater flexibility. Have you ever needed a query that Django didn't support out of the box? Let me know in the comments. I would love to hear your cases. See you next time.